Hey guys, it's Chris. I will show you today how I built this camera light controlled through Bluetooth from an Android app. So let's get started. I needed this type of lighting device to make some cool images for social media sharing, and after searching the internet for a ready-made product, I noticed that it's a bit expensive to get a color controllable lighting gadget. So I decided to produce my own one. By the way, all the making files are available for free download in the description of this video. First, I defined the microcontroller that I will use. In this project, I used the Atmega328, similar to the MCU of Arduino Nano board. The LED pixel reference, which is WS2812 addressable RGB LEDs, you still can use any RGB reference of the WS28 series. The power source, which is 3 rechargeable batteries. Unfortunately, I will not add a charging circuit here, otherwise the device will be a bit bigger. The device size is around 50 by 70 mm and the connection to the phone app is made through Bluetooth. I move it to Altium Designer and I grabbed 42 LED pixels to arrange them later in a 7x6 LED matrix. Considering the LED datasheet, each LED has to be equipped with a 100 nanofarad bypass capacitor, but it's okay to place one capacitor for each group of 3 LEDs as long as the pixels are close enough to each other. I also brought the Atmega microcontroller and its necessary crystal. I managed to program the device through Arduino IDE, so I added the CH340 USB to TTL converter and I added a USB-C connector to the USB data line. I also added the batteries bracket and the Bluetooth connector. The whole device power will be controlled through this slide switch. I get all my parts from Octopart. There you can search for the needed components using their manufacturer part numbers and easily download them to get them added to your Altium schematic. I then transformed this schematic into a PCB design, and the first thing here is setting the device size. As I mentioned earlier, it has to be a 50 by 70 mm. I then arranged the LED pixels in a 7x6 matrix and set them to the top layer with the bypass capacitors. All the rest of the components are set as bottom layer parts and arranged properly to fit the device size. I didn't get the 3D model of this battery bracket, so I designed it myself and saved it as a step file format, then I added it to the battery component 3D files. And here is a 3D view of the designed circuit board. After getting the design gearboard files ready, I moved to GLC PCB and I uploaded my design files to place a PCB order. I set the color to white solder mask, quantity is 5 pieces, and this is the minimum PCB settings for the lowest price. I also ordered the top and bottom stencil to help me with the board assembly. 6 days later, I got the goods delivered very well, and here is the blue box bringing my circuit boards. The stencil is also looking good, and this way I'm all set to start the assembly. I used stencil to equally deposit the solder paste on the top side of the board. And then I placed the bypass capacitors and the RGB LED pixels. I then used this small MHP30 hot plate from Miniware to complete the pixels assembly. After getting the top side soldered, I used some flux removal solvent to clean the board, and then I move it to the bottom side. The same process will be followed here except for the solder paste. I used a lower temperature profile solder paste to get it molten faster, and this way I keep the top side components connected. I used the assembly app provided by Altium365, which helps to indicate the correct placement and orientation of each component. No way to use the hot plate here, so I reflowed the bottom side of the board using the hot air soldering station. The final step is soldering the Bluetooth module, but make sure that you set a customized Bluetooth name to identify the device. You can do this through AT commands, and if you don't know how to achieve this, you can watch my tutorial about Bluetooth settings configuration. I used the same serial port for programming and Bluetooth communication, so I added this header connector to select in which way I use the serial port. Placing the jumpers in this position will allow programming, and placing them later in this position will activate the Bluetooth communication. You still can change this by placing the Bluetooth to other pins of the microcontroller, generally pin 2 and 3, and you use the software serial library to create a software serial port. Here is the code that I prepared for a Lightning device, and it will make the device able to receive serial data to control the pixels, color and brightness continuously. I placed the jumpers to programming position, plugged the USB cable, and uploaded the code to my device. Then I put the jumpers back to Bluetooth position. The final step is preparing the device housing. I made this design for the top and bottom covers and 3D printed them. As always, 3mm threaded inserts are always good help for assembly. As the device light screen, I used this white matte plexiglass of reference WH02SC, and it fits perfectly to the gadget top side. I then created this Android app to control the color through this color palette and brightness through this slider. But first, I must connect the app to the device through Bluetooth. Since I already made two devices, I called them Camera Light 1 and Camera Light 2. As soon as I connect the device, it will make a quick flash, and now I can set the color and brightness smoothly from the app. I already have unique color panels, and I noticed that the panel changes light color from warm to cold white every time I turn on and off the panel. So I decided to make the same thing for my devices by playing a bit with the EEPROM of the MCU. And this option also works very well. Every time I turn on the device, it changes automatically the light color from warm to cold daylight. That's it for today, guys. Do not forget to leave your thoughts about this gadget in the comments section. One last thing, make sure that you are doing electronics every day. It was Chris. See you next time.